Alright, continuing on with the multiplication of polynomials. So we've done a monomial times a monomial times a binomial, and a binomial times a binomial. But we can multiply any two polynomials together as long as we expand them out correctly and use our distributive property. So for the first example, it says a rectangle has a length of 5x plus 2 and a width of x squared plus 2x plus 1. Which means that if I'm finding the area, I'm going to multiply the length, 5x plus 2, times the width, x squared plus 2x plus 1. Now, I could do this using an area diagram, or I could do this using a distributive property, which they have started for us. So if I'm doing an area diagram, then I'm going to have the two terms, like we've done before, on the top, 5x and 2. On the other side, I actually have three terms, x squared, 2x, and 1. And we can see here that if we have a binomial or two terms multiplied by a trinomial which has three terms, there's 6 different multiplications that need to take place. So now I can multiply this out. I'm going to get 5x to the power of 3. I'm going to get 2x squareds, 10x squareds, 4x's, 5x's, and 2. You can also see that, like in our previous cases, we can see in the area diagram what our like terms that we can combine are. So, when I combine my like terms, I get 5x to the power of 3. The 2x squared and 10x squared gives me 12x squareds. The 4x and 5x gives me 9x's and a constant of 2. If I'm using the distributive property, I'm saying that I'm going to multiply the first term in the binomial by all the terms in the trinomial, and the second term by all the terms in the trinomial. They've already expanded it out for us in the first step. So I just need to make sure that I multiply out properly. So, just like in the last case, I'm going to have 5x times x squared gives me 5x to the 3. 5x and 2x gives me 10x's squared. 5x and 1 gives me 5x's. 2 times x squared gives me 2x squareds. 2 times 2x gives me 4x's. And 2 times 1 gives me 2. Then I'm just going to combine my like terms. I have my x squared and my x squared. And I have my x and my x. And I get the exact same result as when I use the area diagram. 5x to the 3, 12x squareds, 9x's, and 2. So, if I'm expanding and simplifying, I can use either method, and it's okay for you to use whatever method you're comfortable with. If you're doing a written response on a test, both of these are acceptable. For this case, I'm going to use the distributive property, and I'm going to say that this is going to be the same as taking the first term in the binomial x squared and multiplying it by 2x to the power 3 plus x minus 5. I'm going to take the second term, which is negative 4, and multiply it by 2x to the power 3 plus x minus 5. When I expand this out, I'm going to wind up getting 2x to the power of 5, x to the power of 3, and negative 5x squareds. When I multiply the second step by negative 4, I get negative 8x to the power of 3, I get negative 4x's, and I get positive 20. And you can see that the only like terms here are the x cubed and the x cubed. The other ones don't match because they don't have the same variable with the same exponents. So I have 2x to the 5s, I have negative 7 x cubes, negative 5x squareds, negative 4x's, and positive 20. I could use the same principle with the second one and say that I'm going to multiply all three of the terms here by the binomial. So I could say that this would be the same as 2y squared times y minus 6 minus 3y times y minus 6 minus 7 times y minus 6. And the same principle works. As long as I distribute the coefficients into the brackets properly, I'm going to get 2y to the 3. I'm going to get negative 12y squareds, negative 3y squareds, positive 18y, negative 7y, and positive 42. I combine my y squareds, and I combine my y's to group those like terms. 2y cubed minus 15y squareds plus 11y's plus 42. When we get to example 3, remember, everything is the same as what we have done in the past. I'm going to multiply my more complex products first, and then I'm going to multiply by the coefficients afterwards. So I can say that I have 4. I'm going to use the square brackets for multiplying this out. I have a times a squared minus 3a minus 6 and negative 4 times a squared minus 3a minus 6. I'm subtracting from that. For a times 4a plus 3 and negative 3 times 4a plus 3. Now if you wanted to, and you notice that in the second set, they're what we call conjugates, so they're going to multiply to a difference of squares, you can jump right to that step. So when I multiply this out, I'm going to get 4, and this is going to become a to the 3 minus 3a squareds minus 6a's minus 4a squareds plus 12a's and plus 24. And this is going to give me 16a squareds minus 9. Now, if you want, you can combine the like terms in here before you multiply by 4. Or you can just multiply by 4 and combine all the like terms at the end. There is no right or wrong way to do that. So if I just expand everything out, then I'm going to get 4a cubes minus 12a squareds minus 24a's minus 16a squareds plus 48a's plus 96 minus 16a squareds and plus 9. And once again, I'm looking for those like terms. A squareds all combine. My a's are going to combine. And my constants are going to combine. And if I combine them properly, then I get 4a cubes minus 44a squareds plus 24a's plus 105.